So hello everyone and welcome to this igus webinar. This is the last one of 2017 and this one is about our product e-spool. Thank you for joining us and taking the time. Hopefully this will be some useful information for you, and there is a box at the bottom marked ask your question, so please feel free to do that at any point during the presentation, and then at the end of the presentation, at the end of the webinar, I will try and answer as many questions as we have time to do so. So as I said, you're very welcome, and let's launch into this webinar, which is entitled e-spool, cable reeling without slip rings, for stage, theatre and venues and many other places too. So first, I'd like to give it a little bit of background, particularly as to the marketplace that we're talking about here. So predominantly, we've been talking about theatre in this webinar. There are other areas this is appropriate to, but this is a market which is very, very important. What's interesting is you don't have to look very far in the media before you see that this is a market where there is very solid growth in revenue. Even against the very changeable financial backdrop we've had over the last few years, you can find records being broken all the time in terms of attendance and in terms of turnover, box office takings and so on. And that's not just true for the UK, but that is true worldwide. We see that in America and all around the world. One very important thing is that the UK is absolutely a centre of excellence for development of the theatre design and technology industry. So this is both from the perspective of architects in these areas, but also theatre engineering companies, those that put the technology together. And of course, we have a world-class set of theatres around the UK as well, which are very well known. And this is a market which has been very robust and has contributed a lot to the economy, as I said, in the UK as well as other places. Now, if you have a cursory look anywhere online, you can see some of the technology that we used to be using in the theatre industry and stage and set industry in the past, and compare that to what we're using now, and you can see just a colossal change in the last few years. So some of the simplest things have made the biggest difference, so things like the move to LED lights, but also overall control systems. So the advent of the computer has allowed us to have much more control over what happens, and allow people to control a much broader range of technologies that are being employed all at once in a movie or a theatre or in a live show of some kind. So this is audio, visual, many different aspects, and digital control have added a huge amount to that. Now, of course, anywhere where you have moving set, so either lighting or sound or set, then you will almost certainly need to carry cables to that for power, for data, for signals. And the current state of the art for anywhere where you have moving power has been cable reelers. Now, cable reelers, again, a very quick cursory look online, we'll see that the cable reelers are very common, and very good, very reliable, very good product that served the industry very well for a long time. One of the key characteristics of a cable reeler, as you can see here, is that it is a slip ring system somewhere within there to transmit the power as it rotates, and then the reel of the cable itself that pays off. And finally, you have either a spring or a motor to retract or to bring that system back up, particularly areas where there's a vertical travel, which is one of the most common applications for trusses that move up and down or set that moves up and down. So this is the current state of the art, and as I said, it served the industry incredibly well for a very long time. But it does have some limitations, and those limitations are becoming more and more obvious as we enter this very multimedia age and the age of very high-speed data and of digital services that I've just spoken about. So the crucial one is that the slip ring is the core of that product, of the cable reeler product, and that has its limitations. In some ways, the limitations are to do with reliability of corrosion or debris or anything getting into there. That's not actually generally a problem for this industry. It can be more for where their reel is outdoors and in other environments such as cranes or ports or places like this. But for the studio and theatre and venue type industries, that's less of an issue. The bigger issue is that slip rings limit on the mixture of services that you can have, and it becomes quite complicated when you're trying to put bus systems and power systems, and at very best you need to put separate reels for some of these systems, or at the very, very least quite a complicated composite cable, and a complicated cable like this will invariably be expensive and nearly always end up being bespoke. Another crucial thing is that if you ever want to use fluids or fiber optic cables or something like this, then actually that becomes difficult, almost impossible using slip rings, and if it is possible, it's incredibly expensive. So you're either trying to build a composite cable, and you are also limited on what you can use. One of the key backdrops here is the ever-increasing need for data speed. What I find very interesting is that at igus we have exposure across a big range of industries, and one thing that is really obvious to me is that the move across the different standards of the Cat standards for Ethernet has been quicker adopted in these industries than anywhere else, even in automation. So the move from Cat5, Cat5e to Cat6 or Cat6a, which is common, and then on to Cat7 is been rapidly driven by this industry more than any other. And the logical conclusion for this, for cables, ultimately will probably be fiber optics, because the data speeds can get higher and higher without the limitations that copper cables will have. Plus, physically, they're in some ways a bit easier to handle because they're lighter, and you can put a lot more in the way of channels and data down the same fiber optic system. So all of these points that are here do mean that the cable reeler is starting to struggle as a concept to keep up with the demands and some of the bespoke requirements of venue type applications for moving cables and hoses. So this slide shows the approach that igus took to try and solve some of these problems. So a few years ago, we looked at these problems and thought we must be able to bring our knowledge of cable management systems as one of the products that we make, what we call e-chains, energy chains, to bear on these problems and see if we could come up with something new that would solve some of those issues for our customers in these markets and these industries. And this is what we call e-spool, and this has been in operation for quite a while now, but it's something that's still quite new for some of our customers. So let's start looking through the points as I show them on this slide. So the first one is to break the need for a slip ring, and this we achieved with a conical energy chain that we call twister band. And this allows an end-to-end cable from connection from the very top, where it enters the system, round out on the drum and to the bottom. There's no breaks in there. There's no copper slip ring contact. This is a continuous end-to-end connection. Then the main drop, instead of being a composite cable, is an energy chain which contains multiple cables, and it gives physical guidance and physical protection. So it physically surrounds the cables, unlike a composite cable which relies only on its outer jacket for protection, and also the guidance, so that there's a minimum bend radius built into that, and it keeps the cables in good structure. Also, different cables can be fitted together within the e-chain, and that means that instead of having a single large, quite stiff composite cable, we now have single cables for the different functions laying side by side. Indeed, that can also be fiber optic, air, water, whatever you needed, and they can be side by side. In addition to that, you can actually extend the system, lock it off, and then replace a single cable. So for example, if you have a Cat5e system, you could come back at a later date and open the system up and replace it with a Cat6a or Cat7 or fiber optic cable. And this gives you the ability to upgrade a system without a new composite cable or any re-rigging. Finally, a system that's probably fairly common to most of the reeler systems is that it's spring driven in most cases, and that retraction spring can be tuned as you would expect to match the application, so that the system retracts itself but doesn't overly pull on whatever it is that you're lifting up, so lighting truss or sound truss. So twister band. So as I mentioned before, the real breakthrough for us was the development of the conical twisting chain called twister band. And this allows a true end-to-end connection for cables. Basically what it is a system that wraps around and rotates in two orientations, one around a core, and then secondly this sort of conical helix of chain that rolls around. And this allows anything up to 7,000 degrees of rotation. We have different sizes of this, and crucially it allows different media to be combined together and changed as well. So a little video just to show what that looks like. So you can see it's a link by link construction, just like a true energy chain in every other way, but it's built in these two axes, one axis round this way and then one axis in the helical sense that rotates around and holds the cables in their correct line of movement. Each link can be opened, which can allow the fitting and unfitting of the cables, and that is the part that I've just mentioned, which offers you the ability to upgrade later on in the life of this product. So moving forward, we have a fairly mature family now of e-spool types, and I just want to run through these now so you can see the kind of capability that you can get out of this concept. So first of all, we have our e-spool mini, we call this. This is up here. This system is a 2-meter extension, can hold 3 or 4 small cables, and that unit is a roughly 300 millimeter cube. Again, spring retraction. We then have our manual system here. This is for one single cable where you need it, but it also has a ratchet on it, so a cable can be pulled out, attached to something, and then pulled to release the ratchet and back in again. That's for applications where something maybe needs to be pulled out to be charged or to connect, but then needs to be completely moved away for other periods of time. Then we move on to our e-spool standards, which is shown here. And this is the bread and butter of our range. And there are 3 extension lengths for this system, a 4-meter, 7-meter and 14-meter extensions. And we do what we call a single and double-sided. And what that simply means is if we need more cable capacity, we can put a second twister band on the opposite side of the drum. And then we can make the central feed, the energy chain that drops down or up, wider to take more cables. And we'll talk a bit more in a moment about why that is very important, but it's to do with cable capacity, and we can make a wider system. And on the biggest of these systems, the 14-meter systems, then you're looking at something like 800 to 900 millimeter cube, roughly, of units. Here you can clearly see the spring cartridge, which is a unit which is replaceable and tunable. So here you can attach a spanner or a drill or whatever to turn that to increase or decrease the tension to suit your application. But the whole cartridge can be replaced if that needs to be done at a later date for any reason. And finally, once we go past 20 meters, then the loads that are involved in pulling cables back up, particularly in the vertical plane, start to get a bit big for springs, and this allows us to, we use a motor now to allow us to offer something bigger. So our standard sort of motor solution is around about the 25 meters, but we know that we can go bigger than that. We think we can probably get up to 50 meters if we need to with these. Just to say, so the system is driven, but crucially, at the other end of this, the moving end that moves up and down or wherever it is moving, this will be a closed loop control system. And now what that means is there's an encoder at the end which detects the motion and then starts or stops the motor here to pull the system up and down. Why that's really, really important for you is that this means that the system doesn't have to be embedded in any kind of control system that you're using anywhere else. So this is a totally standalone system. You bolt it onto your moving set or truss or whatever it is, and this will follow it as it moves in and out. So that's the standard range as it stands today, and we're expanding that all the time. What I'd now like to share with you is some of the rules and some of the guidance for the use of this product to make sure that you clearly understand what it can do and the limitations that it has. So first of all, cables must be segregated correctly inside the twister band and the E-chain. What do we mean by that? Well, because these cables are not composite, they're not all in one unit, that means that you have multiple cables. So you might have DMX plus fiber optic plus power plus Cat6A. Now, if we were just to fit these inside the twister band and inside the chain that pulls down from the drum, without any segregation, they would get twisted and start to cause problems, because there's quite a lot of complex twisting going on inside that system. And we know that in order to have a long and happy life of the cables, then that needs to be done. The good news is that we provide separation and systems that will go into those systems and keep the cables separate. Second point is that cables can only be stacked in the twister band. That means they can be stacked too high within that, but inside the chain itself, we can't do that. And the reason for that is, if you imagine as this reel pays off, if we had cables on the inner and the outer side of the chain, then the outer side would have a longer path length as it coils and uncoils than the inner side, and that would mean relative motion, which would not be good for the cables. So within the chain, we have to lay the cables out side by side and not stacked up, and that's why we have to use a wider chain to carry more cables. Cables must be strain relieved at the ends, so both ends of the twister band. I'm going to refer to the slide before here. We have a strain relief system here and one at the end of the chain as well. And this allows us to properly tie off the cables. What we find is, particularly with vertical motions, cables will start to prefer one direction, often where gravity is acting, and that would lead to cables being pulled through the system, and that we are trying to avoid. The next point is that and this is a crucial one to be aware of, is that currently the maximum single cable diameter we have is 17 millimeters. Now what that means is that that cables that have larger units of numbers of cores, we typically try to split up. So for example, if you wanted a 36 core cable at 2.5 millimeters squared, that would be bigger than 17. So we would maybe split that up into 3 cables of 12 cores. We could, in theory, make a twister band that takes a bigger capacity, but our experience is that once you start to get cables bigger than that diameter, they become very stiff and very hard to move, and that can have a knock-on effects further along, which we don't necessarily want to have for these type of applications. So our experience is to split things up. So smaller cables, DMX and Ethernet and coaxes and so on, are pretty easy. They always come in under that. It's generally power cables, but as I said, our solution is always to reduce that to a different denomination of cores, which we can do very, very easily, and that's worked very successfully so far. Finally, and one very important thing that we have at the moment is a limitation on the extraction and retraction speed of the system of 1 meter a second. Actually, we haven't had any applications yet where that's been a challenge, but it is something to be aware of, because that allows the spring or the motor to keep up with the system as it pays on and off, and not have any slack of the system moving around. So just to give shine a little bit of a light into how we develop the product, and a good place to look is in our test labs. And I'm just going to show a short video here, which shows the igus e-spool in the test lab, and it also shows some features which are good to point out when you can see the system running. So you can see the system. Now this is would be, for many of our customers, this would essentially be upside down, so it's mounted on the floor and the system is moving up and down. Actually, often this would be the other way up. And what you can clearly see here is the chain paying out with the individual cables running nicely side by side within the chain, and you can see the purple one will be an Ethernet and the blue will be an air pipe. And you can see that as that moves up and away, and you can see clearly how the chain gives physical protection. And then here, as this moves, you can see that the conical rotation of the e-spool, of the twister band rather, and here is a twister band isolated, so you can see how that moves. And that's just the subcomponent within there. So you can see the conical rotation as this moves around the central hub. And this is the same here on a bigger scale on the actual e-spool itself. This application, as you can see in the video at this moment, is running horizontally, and there's no support on this, so you would have a shorter length available that this would work with, otherwise you'd get things sagging down, but with some support that can go just as far horizontally as it can vertically. If it was unsupported, we would have to look at that because there'd be a huge amount of tension involved in keeping that straight. So now I just want to show a little bit in the way of a very specific application example which highlights what the system actually looks like when it's up and running inside a venue. So this is a system that's running in Liverpool University on a speaker array, which has to be moved up and down. And you can see, so what I said before about 1 meter a second, this is very typical of the kind of speeds that are being moved at, which are clearly far below that. And you can see that the energy chain system with the cables in it is running in parallel with the main winch chains, which makes it look very neat. The whole system here, another thing to notice, is black, but it blends in, and typically that's what all of our systems are requested to be, and it blends in with what else is there. Another thing to note, which you'll see in some frames in a moment, is that there's only 2 cables here. And so clearly you can see that there'd be room for expansion if the customer needs to add something in the future, some alternative cable filling. So this one here, for example, is a little bit more full. This side is more empty. And again, it's just something which offers capacity for any changes in the future. So that is a very good example of how something looks when it's fitted on a standard vertical motion in a venue. So moving on, another area that we need to pay very close attention to when using a system like this is the cables themselves. And one thing that's really important to take away from today is that if you use a reeling system, you should always use a good dynamic cable. The danger if you don't is that because of all the complex twisting that's going on here, in order to avoid a slip ring, then a standard static cable really will not last long in there. And even if you have a low duty cycle, it's a very non-linear effect, the damage on the cable, and it could be very few hundreds or thousands of cycles before a cable could be completely destroyed. Now, we develop our own range of what we call chain flex cables that are suitable for use in energy chains, and we guarantee these for very long life in flexing use. And so that we've put a lot of technology and know-how into those to make sure that they work. And this application with e-spool is particularly aggressive in terms of the twisting part of the twister band part of the motion. In some cases, with some more fragile screened cables, it might even be necessary to use our what we call CF robot cables. This is a range of robotic cables where screens, as they get twisted, can quite often break up very quickly. So we have a range of screens and screened cables which will work under very severe twist. Particularly things like bus cables, and we have these cables there as well. So within our range, we have everything that we think we need to cover almost any application using an e-spool, and that is something that's crucial. And we very strongly advise against trying to use a standard semi-static cable because it will break up in a fairly short time. And we think that the cables that we have to offer here will be a very, very good match for the e-spool. And in fact, for ease of use for yourselves, we would very strongly recommend just letting us fit the cables ourselves anyway. We would expect to deliver this as a fully harnessed package, and the benefit for yourselves is that the whole system comes on a pallet and you simply bolt the system up and then it's ready to use. So you tell us what cable types and also what tail lengths, and indeed if you want connectors added, we would do all of that, and then we would fit that into the chain, into the twister band, and the whole system will be ready to offer up. And it will be ready to fit according to the tail lengths that you give us. We also have the ability to offer on-site support, both beforehand to measure up, but also for installation as well afterwards. So we can visit site with you and look at what you need to do there. And even at the end, when you have to come to actually fit the e-spool up there, we can either do that or we can advise and be there to support with that. We offer as much of that service as you need. In addition, we have a number of accessories that are quite important for the applications that you might get with a spooling system. In addition to things like different spring cartridges, which I've already mentioned, one of the common ones we get asked for is a roller system. The reason for this is because as the E-chain pays off of the reel, the diameter gets smaller, and that would move where the chain would go through in the floor. Now, if you've got a totally open system up in the roof or on the floor where that movement doesn't matter, then that's fine. But if you need to, for example, pay the chain out through a very small letterbox sort of size hole that needs to be the same as this pays off and the diameter comes down, then you'll need a roller for that as well, which we offer that as standard. We can also offer the energy chain. Conventionally will only will move in one direction. It will have a bend radius in one direction. Typically these applications are only going to move straight anyway. What we can do is offer a chain that, as it moves down here, can reverse bend. It can bend up that way, or indeed it can bend the other way, and that offers some options, particularly for things like moving set, where something might have to move in different directions once it's gone through the ceiling or above the floor level. In addition, we can offer different colors for the metalwork, and also to some extent for the chain itself as the chain moves. So the default color for everything, as I've already said, is black, and in most venues that's absolutely fine. In some applications we make the actual circular drum part in yellow. We've done this in a number of factories because they offer a visual cue of danger of something moving. And we, in theory, can also offer the plastic parts, as I said, in other colours as well. The one thing to be aware of is that when you mould plastic with different colours, it doesn't always have the same strength once the pigment is in there. So it's something that we would examine with you and make sure that the colour that you want that in for the chain parts is not going to compromise the strength of that product. So again, something you can ask us about for any specific project. At the start of this presentation, I said that we were specifically looking at theatres, studios, venues, and so on. Actually, there's a lot of other markets where this has gained a lot of interest. The first one has been in the area of cranes. So here you can see a vertical crane system with the e-spool at the top, and this will be feeding something like a load cell or something like a strain gauge within the system to weigh what's on the system and feed that back. The reason why e-spool is a great solution for that is because no weight is being added to what's being lifted, and therefore it allows the ability to get different types of cables down to there and keep the rest of it retracted out of the way without putting extra load onto the beam. An interesting application as well we have in operations for a customer with some wind turbines, and these are used on a telescopic lift and lower system. And again, that was one where in order to have the cable management to feed back from that system, that was quite important that they had a retracting system, and that's being used there. And finally, a very large scale system that we have here, which we have going into operation in some different places, is what we call shore power. This is for a large high voltage or medium voltage cable to go from the land side onto a vessel like a ferry or a container ship, so that it can be under power from the shore rather than running its engines while it's in port and causing pollution. This is becoming a very hot topic at the moment. So these kind of port type applications are becoming important as well. And I said before about twister band, we can develop a bigger version, and that's what we've done here. So for these very large high voltage cables, this is something that we have done, and that allows that to pay out up to some quite long lengths. That's a very, very large system here that would be used for that. So it scales very, very well as well for other applications. Just to mention as well that in addition to e-spool, we still have the very commonly used what we call zigzag, and it often in the market is called flip-flop system, where we take our energy chains and we reverse them at different places and have a system that can cope with a vertical motion and carry lots of different cables in the same way as we can with e-spool. As this video shows, you can have this system. Generally, it's going to be on vertical motions, and generally it will be mounted. The system will be mounted on a truss in a basket. We provide the whole thing pre-made with the basket and the cables pre-fitted. And as the system lifts, the basket catches that as it moves upwards. So the benefits of this system are that it can carry a lot more cables, a lot bigger cable fill weight. The slight negative with that is that, of course, you're adding the weight to the truss that you're lifting. So you need to make sure that your winches can cope with the excess weight that goes onto there. And of course, they're a little bit more visible when it's lowered. That depends whether that matters or not. Normally, trusses will be up in the air at the time. Another little project which I just want to mention as a sideline away from e-spool that we have is something called lift band, and this is an alternative where something like a cable reeling system like e-spool would maybe be overkill for, but you still want something that's fairly small and compact, would be what we call lift band. And this is a system with a spiral chain, so it doesn't rotate, it simply lifts and lowers in and out of this basket. This would be, for example, for 3 or 4 small cables, maybe up to 8 mil diameter, and would go up to 13 meter drop. and all of this would gather up in a very simple basket. So this might be more for small drops with a few cables. You typically might get in a smaller venue or a less technically complex venue requirement. So by way of summary to what we've spoken about today, so with increasing automation, architects, consultants, stage technology companies and theatres are facing ever more moving cables and needing to move those reliably. In addition, those cables are getting more complicated in the sense that they are higher grade in terms of high-speed data, even up to fibre optics. The second point is that conventional cable reels are very good, but they do have their limitations, particularly on the ability to mix different services together or replace individual elements of the services within that. The igus e-spool concept and product range offers a new approach which has a true end-to-end connection with no slip ring and, above all, the ability to mix services. And of course, the cables and services can be changed or upgraded later on in their life, which means you have a system which should give a lot longer life once it's in place. Finally, a key point to notice is that correct dynamic cables must be used and correctly laid out and tensioned, and that we do have certain limits on the cable sizes as well. So that concludes my presentation on the e-spool concept and product range. As I mentioned before, there is the Ask Your Question button on your screens. If you've had a chance to do that already, brilliant, thank you very much, and I'll be looking at those to answer those in a few moments. But I'm going to leave a few seconds now if you want to put your question through now. I'll gather all of these together and then we will make a start on answering as many of them as we can for you. So thank you very much for your attention. Okay, so now it's a good time for us to have a look at some questions that have been coming in while the presentation has been going on. So I'll just launch straight into these. The first one is a great question from Nigel. Is it possible to get 3D CAD files for the e-spools? And the great news is yes, absolutely. We can do that. So if you go to our website, igus.co.uk, you'll find 4 headings at the top of our main web page, and one of which is service. And service will take you to 3D CAD download, and from there you can look through and find e-spool in there. And we have all the main standard types in there as solid formats, SolidWorks, STEP, igus, some of the other specific CAD-specific formats, and also you can output 2D forms of those as well, DXF and DWG of different views of that as you wish. So yes, that should make planning the space that you need for that much easier. Second question, and this one's from Keith, is can the e-spool only be used for vertical movements? That's a really good question, Keith. Thank you for that. So yes, generally we use it for vertical movements, but it can be used for horizontal movements or a combination of vertical and horizontal. That's one of the beauties of the system, is that it can cover 2 axes, sort of an XZ movement, if you will. The only limitation, or the only thing that we have to be careful with horizontal applications, of course, that you've got gravity acting on the system. So as it pulls out, we have to consider the filling and the extension length to make sure that we've got the tension required to pull it back. In an ideal world, what we really want to do with the horizontal application is to have a smooth surface to run it on, and then we can go really as far as we like. But we can do unsupported as well. That's something we would look at for you. So if you have some specific figures, give them to me and we'll work that out. But yes, it can be done horizontally, and indeed a combination as well. And the third question that we have is from Robert, is can e-spool carry compressed air? Yes is the short answer to that. Absolutely, compressed air is completely fine. Again, just watch for the size limit, the 17mm OD size limit, and making sure that we use a reasonably pliable hose that will cope with that sort of twisting and flexing. In fact, the only pressured fluids that we are a little bit cautious about is hydraulics. So the standard systems, hydraulic hoses wouldn't really want to be inside the twister band portion of a standard e-spool. So we generally try and avoid that. However, because of the special products we developed for things like the shore power that can take very large cables, we probably do have some tools there that we could develop something for hydraulics should you need that. But yes, compressed air, absolutely fine. And finally, a question from Antonio. How is the movement controlled in the e-spool power? So very, very simply, there's a drive at the top which drives the e-spool out and more importantly return when it's against gravity. But the movement of that is I think I mentioned briefly, is a closed loop system. So what we mean by that is there's a simple linear encoder on the towing arm on the moving end of the e-spool chain as it pulls out, and that detects whether the system is in movement. That attaches to the flying truss or the bar or the crane girder or whatever it is that's being moved, and the e-spool will detect whether there's any motion. As soon as there is some motion from that encoder, it will start the drive turning to pull the e-spool chain back up in the same direction, and if the motion stops, then the drive will stop. The good thing about this is it's a completely closed loop system. You don't need to integrate that in any way into your control system. It will just work on its own simply by the encoder feeding back into the power system, the drive system that's attached to the e-spool. So hopefully that answers that question. That's all of the questions that we have. I hope the whole presentation has been of use to you. Thank you so much for your time and attention. If we can help and you have a project that you think e-spool might be helpful for, then please just feel free to get in touch with us, give us a call or email us, and all of our details are on igus.co.uk. Thanks again for your time, and look forward to speaking to you in another webinar soon. Goodbye.